Hi, here we go, doing a quick video on limits of trig functions. How do we find the limit of a trig function? Let's look at some basic special trigonomic limits. We have two special trigonomic limits. We have, number one, the limit as x goes to 0 of sine x over x is equal to 1. All right, so if we can create a situation where we have a sine x over x, then that limit is 1. There's a proof that we can go over. I'm not going to spend the time on that, but that's one of the identities that we can work with. The limit as x goes to 0 for the second one of 1 minus cosine x over x will equal 0. So if we can factor things out, we can create that 1 minus cosine x, then we can get 0. All right, let's look at our first example. Here we have example number 1. Find the limit. The limit as x goes to 0 of tangent of x over x. So here's tangent. We know we have a special trigonomic limit of sine x over x is equal to 1, so we've got to figure out, well, what do we do? Number 1 is rewrite tangent x in terms of sine and cosine. So here we go. We have 1 over x, that's that x. We rewrote sine x over 1. And 1 over cosine. I could have put these together as sine x over cosine x, but I decided to split them up so you could see how each of them play out. Okay? Now, we can combine sine x over x because it's multiplication. We can maneuver those around. So we get sine x over x, and then 1 over cosine x. Now, the identity said that the special trig limit was sine x over x was equal to 1, so I substituted that in there. And we get 1 over the cosine of 0. Well, the cosine of 0 is 1. So we get 1 times 1 is 1. So the limit is 1. All right? Okay, next one. We have example number 2. Find the limit. The limit as x goes to 0 of 1 minus cosine x squared. So again, what we want to do is we want to expand this square. This is a perfect binomial, and binomial square. So we get 1 minus cosine x times 1 minus cosine x all over x. We recognize that 1 minus cosine x over x is a special limit right here. Yeah, 1 minus cosine x over x is 0. Okay, so let's go back. So we know that that's 0 times 1 minus cosine x. Well, we don't even have to substitute in because 0 times anything is just 0. So the limit, my friends, is 0. All right, example number 3. It says find the limit. The limit goes to 0 of sine of 3x over 2x. Oh boy, what are we going to do? We have this 3x and we need a 3x in the denominator. So we want to create a situation where we have a 3x over a 3x. So what we do is we multiply the top and bottom by 3 over 3. And then because multiplication, we can move these pieces around 2x over 3. So what we do is we slide this 3 in here for where this is and move the 2 out there. And we get sine of 3x over 3x is equal to 3 over 2. Now, what we do is since this 3x over 3x, this isn't just anything, right? We have to then say let 3x equals some y maybe. And that would be sine of y over y. As just an example, we could use w or p or anything like that. But this is why we get the identity to work. So sine of 3x over x, that identity becomes 1 times 3 over 2. And we end up with the limit of 3/2. All right, hope you enjoyed that. Thanks, have a great night. We will talk to you soon.